Afternoon, we're going to be looking at inequalities today. Three things within inequalities. We're going to be looking at simple linear inequalities. We're going to be looking at simple quadratic inequalities. And finally, if we have time in this video, we'll be looking at graphing regions, but we might save that for the second video. So, let's look at a simple inequality. 4x minus 3 divided by 5 is less than or equal to 3. Now, you did questions like this in previous years, so you might want to pause the video now, see if you can solve it on your notes, and then check back to see if you got it right. From here, a quick note before we do this question. All three of these ideas, you're going to treat the inequality sign like an equal sign. So you're going to treat these like equations. So we treat this inequality, 4x minus 3 over 5 is less than or equal to 3, like an equation. So we just do the same manipulation. The first thing you want to do is times both sides by 5, giving you 4x minus 3 is less than or equal to 15. Okay? Just timesing both sides by 5. From here, you're going to want to add 3 to both sides, so 4x is less than or equal to 18. And finally, divide both sides by 4, so x is less than or equal to 18 divided by 4, which ends up being 4.5. Okay. Now you might be asked to represent this on a number line. So how would you represent this on the number line? So your number line is just there. You might want to pause the video, see if you can remember how to do this yourself. Okay. So since x is less than or equal to, we draw a closed circle at the point 4.5, and since x is less than or equal to that number, we draw an arrow in the direction that says it's less than. Okay. Right, let's look at another inequality now, another linear one. 10 minus 2x is less than x plus 1. So pause the video here and try and solve it yourself. So there are various things you might do at the start. You want x's on one side and the numbers on the other. So the first thing you might do would be to, say, add 2x to both sides. That would be a fine step. That's the step I'd recommend, but let's look at what might happen if you didn't do that step. Let's say you took away x from both sides instead. You would end up with 10 minus 3x is less than 1, just treating the inequality sign like an equal sign. From here, you might take away 10 from both sides. So you get negative 3x is less than negative 9. Divide both sides by 3 at this stage, giving you x minus x is less than negative 9. Now this takes some time to get your head around, so I'm going to tell the answer and let you have a think about it. So if negative x is less than negative 9, well, that really means that x must be bigger than 9. Okay, so think of an example that works. If x is 10, 10 is bigger than 9, negative 10 is less than negative 9. That works. If x is 100, 100 is bigger than 9, then negative 100 is less than negative 9. So that all makes sense with the inequalities shown there. A different way to show the same thing is, well, if negative x is less than negative 9, if you add x to both sides, then you get 0 is less than negative 9 plus x. Then if you add 9 to both sides, you get 9 is less than x. Or, said in a different way, x is bigger than 9. So it all works with the maths. Now I want you to represent this on a number line. Pause the video and see if you remember how to do it. Okay, so since x is bigger than 9, we will draw an open circle, because x can't be 9, but it's anything bigger than. So open circles for bigger than but not equal to. And since it's bigger than, we draw the arrow going to the right. Okay. So, next, let's look at a simple quadratic. You won't get quadratics any more challenging than this one when there are inequalities involved. So, we're going to treat this, first and foremost, like an equal sign. And I'm going to write the equal sign, x squared is equal to 16. So if x squared is equal to 16, what does that mean? That means that x is equal to plus or minus 4. Okay. Now, I want you to consider x squared and some numbers for x. So, let's say if x is 5. 5 works in this inequality because 5 squared is bigger than 16. 6 works because 6 squared is bigger than 16. 7 squared is 49, bigger than 16. But some other numbers work as well. 2 wouldn't work, for example, because 2 squared is 4, which is not bigger than 16. But negative 5 works because negative 5 squared is 25, which is bigger than 16. Negative 6 also works because negative 6 squared is 36, bigger than 16. And same for negative 7. So actually we have kind of two sets of solution that work. So x could be bigger than 4, but also x could be less than negative 4, i.e. it could be negative 5, negative 5.7, negative 6, negative 100, and that would work in the inequality. So can you pause the video and graph and represent this on a number line? Okay, so once you've had a go, you should have done open circles at 4 and minus 4. At minus 4, because x is less than minus 4, the arrow goes to the left, and at 4 it's an open circle, and because x is bigger than 4, it's to the right. So that says x could be anything sort of on that arrow, but x can't be anything between those open circles, so x couldn't be 0, for example. Okay, I'll stop this video there, and we'll look at the next video, or the next subject in another video.